Math Champions. Welcome to Math with Janet. I'm Janet Moore. Today's topic is measurement conversions. We are going to do an activity called inches and feet and yards. Oh my. This is designed for 4th grade students and targets standards 4.md.a.1 and 4.md.a.2. Even though this activity targets 4th grade standards, it is designed specifically to be reused in 5th grade and 6th grade to go from those 4th grade standards and lead into the 5th and 6th grade standards nicely. The only math supplies that we're going to need for this activity are some rulers, a yardstick, and some colored markers. Okay, Math Champions, it's time to get started. Let's play math. A typical conversion that 4th grade students might be asked to perform will be something like convert 4 feet into inches. Now, several 4th grade students could probably perform this conversion without too much difficulty and without any extra help. However, we're going to take this relatively simple problem and use it as an opportunity to build a tool that will be helpful for us when we get to more difficult conversions. Rather than approaching this simply as a multiplication problem, we're going to take this opportunity to think about the structure of these length measurements and the relationships between the different units that are involved in our conversions. If we want to convert from 4 feet to inches, we have to really think about the relationship between feet and inches. I would recommend kicking this activity off with some measurement aerobics. If you haven't seen that video, go look it up. That's a great warm-up to this conversions problem-solving activity. If we want to convert from 4 feet to inches, we have to consider how many inches would it take to build up a length that's the same as 4 feet, the same as 4 of these foot-long rulers. 4 foot-long rulers won't fit on my screen here, and so what we're going to do is use these concrete ruler tools to build a pictorial representation of our 4 feet. I'm going to let that represent 1 foot. From looking at the structure of this ruler, we know that 1 foot is also 12 inches. So there's the first foot in the 4 feet that we need to build. And we know that that next 1 foot length is also made up of 12 inches. And we've got that next 1 foot also equaling 12 inches. At some point, it's a good idea to start abbreviating FT for feet and IN for inches so that students make an organic connection with those abbreviations to understand what they mean and to connect them to the appropriate units. And now we have this diagram that seems simple and almost obvious at first because it really just says that 1 foot is 12 inches and another foot is another 12 inches. Yet this simple diagram can be a very powerful tool for performing conversions in meaningful ways and for doing some good problem solving with these measurement units. At this point, it's a good idea to ask students, how does this diagram act as a helpful tool for performing this conversion, for turning 4 feet into inches? And some students might recognize that 1 foot is 12 inches and another foot is another 12 inches and another foot is another 12 inches and another foot is another 12 inches. And so they might say that we could take 12 plus 12 plus 12 plus 12 to get the total number of inches that make up those 4 feet. Or another student might say we have 4 groups of 12 inches, so we could multiply 4 times 12 to perform that conversion. And again, both of those are perfectly appropriate ways to perform this particular conversion. However, we're going to pause and play around with this diagram for a little bit longer before we wrap up this problem. We're going to add on to this diagram just a little bit in order to turn it into something even more powerful for the work that we have to do. At that point, we've gone 0 feet and that matches up with 0 inches. And when we get to the end of our diagram, we've gone a total of 4 feet, which matches up with 48 inches. Now, how is this helpful to us? Well, first of all, it confirms that 4 feet converts into or matches up with 48 inches total. But beyond that, we now have a tool for solving other measurement conversion problems as well. For example, some students might see right away that they could multiply 8 times 12, that if we extended this diagram out to 8 feet instead of just 4 feet, we would have 8 groups of 12 inches. So they might easily be able to say we could add 12 plus 12 plus 12 plus 12 plus another 12 plus 12 plus 12 plus 12 in order to get those 8 feet. Or they might say we have 8 groups of 12 inches, so 8 times 12 will give us the correct answer. However, we can even get more creative with this than that. Several students will see that if 4 feet matches up with 48 inches, we need twice as much to get to 8 feet. And so rather than taking 8 times 12, they might say, well, I need 2 chunks of 4 feet. 4 feet matches up with 48 inches, so we need 2 chunks of 48 inches. 48 times 2, or 48 plus 48, gives us 96 inches. Now what if we were asked to convert 7 feet to inches? Once again, we could multiply 7 times 12. We know that those 7 feet are 7 groups of 12 inches. We could use repeated addition and add a whole bunch of 12s together, or we could use multiplication and take 7 groups of 12, 7 times 12. But we should also ask students how they could use the information in this diagram, in this tool that we have set up, to get that 7 feet converted into inches in other ways as well. And some students might say, well, 4 feet plus an extra 3 feet will get us to 7 feet. And so 48 inches plus an extra 36 inches will give us the total number of inches in 7 feet. Other students might say, we already know that 8 feet is 96 inches, so what if we started with that 96 inches and subtracted 1 foot? 8 feet minus 1 feet would get us to 7 feet, so 96 inches minus 12 inches should give us the number of inches in 7 feet. However you approach it, students should be able to figure out that 7 feet is 84 inches. Do we want students to be able to multiply in order to convert from feet to inches? Yes, we do. But we want that operation to be built on an understanding of the structure of these length measurement units and the relationships between the units. The more students get to think about these problems in a variety of ways and use a tool like this to really explore the structure and creatively problem solve with it, the more they're going to understand the relationships that are involved in these conversions. And even though it's beyond the standards of 4th grade, with a tool like this, it is not unreasonable to challenge 4th grade students by giving them some problems like this and seeing what they can do with them. If a student has a tool like this, they'll easily be able to see that 40 inches, if we go along our inch markers, is going to be past 36. It's going to be more than 3 feet. And how far past 36? Well, you could either count up or you could do some subtraction and you would say that you've got an extra 4 inches. Even a 4th grader could figure out that 40 inches is 3 full feet and 4 extra inches. Now, what your students don't know, and you don't necessarily have to tell them, is that hidden in this structure is something that they are going to learn about in 6th grade, something called a double number line and another thing called a ratio table. And if you just kind of imagine a number line here that counts up in units that are small enough to get to 12 by here, and then 24 by there, and then 36 by there, and then 48 by there. And another number line up here that counts up 1, 2, 3, 4, and so on, when we set those two number lines side by side, they're called a double number line. And even as we were solving that problem about 40 inches, it was like we were using this as a number line to go all the way over here to 36 and see that it matches up with 3 feet. And then to count 4 beyond 36 to get to our 40 marker. We were kind of treating this as a number line in order to do that problem solving. And that's exactly where students are headed with this concept in 6th grade. In 4th grade, the other side of this standard is to take this information and to create a 2-column table. Now, the most powerful part of approaching measurement conversions in this way is that this diagram that we built becomes a tool. And no matter which measurement conversions they're doing, students can build a tool similar to this one to help them reason and problem solve about those conversions as well. So for example, if students are asked to convert 5 yards into feet, they can use their knowledge of how many feet are in a yard. That relationship then can be the basis for building a similar tool that relates feet to yards. And now in the same way as before, this can act as a tool for reasoning and problem solving about yards to feet conversions. These same numbers also act to fill in a 2-column table relating yards and feet this time in a way that helps students understand what the meanings of the numbers in this 2-column table are. If students are asked to convert yards to inches, they can actually just extend this diagram that they've started down here, and they can say that each yard is 36 inches. And so they can use this as a starter for building yet another tool that will help them with yards to inch conversions. A diagram like this can even be helpful for non-length conversions. Consider the example of converting between pounds and ounces. If we know that 1 pound is 16 ounces, we can use that relationship as the basis for building a similar diagram. Again, along the way, we're getting our students used to thinking about ratios and reasoning about those ratios before they're ever even introduced to ratios. We're getting them used to thinking about double number lines and to thinking about ratio tables before they ever get a formal introduction to those concepts in 6th grade. And along the way, we're building a sense of measurement so that students will understand the meanings of those conversions when they perform those calculations. This has been Math with Janet. I'm Janet Moore. Thanks for playing math with me.